Welcome to Lunchbox Sessions, bite-sized industrial training.
Hello, this is Carl from LunchboxSessions.com. This is part 2 in our series on hydraulic system schematic reading. In part 1, we focused primarily on the hydraulic power unit at the very bottom of the diagram. In this video, we'll look at the directional valving and the pressure valving that is more in the center of the diagram. Let's zoom in and get started. As pointed out in the previous video, flow is provided by a fixed displacement pump. Flow moves towards the valves but first passes through a check valve. This check valve is often there so that any residual pressure left in the system above will not ever backspin our pump when shut down and turn our electric motor into a generator. Also, off to the right, we see a normally closed, a normally blocking pressure valve. This is our main system relief valve. Moving upward from the check valve, we find that flow is already circulating and that our pressure color indicates that we are in a low pressure condition. This makes sense because our directional valve is known as a tandem center, or more simply is known as a P to T center, circulating the pump back to tank. This is helpful in a system that has a fixed displacement pump so that we are not constantly pushing fluid over a spring-loaded relief valve and creating heat at a time when we don't need the hydraulic cylinders to move. To learn more about the tandem center valve, see our video Directional Control Valve Basics Part 2. A few accessories off to the left side include pressure switches and a pressure gauge. The pressure switches may be used by the control system to trigger alerts if pressure is too high or perhaps too low. Let's go back to that directional valve and notice that it is a solenoid-controlled, pilot-operated valve. This means that we need both an electrical signal and hydraulic pilot pressure to move the very large valve spool inside. This is a simplified symbol. For more on this type of valve, see our video, Solenoid-Controlled, Pilot-Operated Directional Control Valve. Off to the right, we see a drain line showing us that the pilot fluid that was used to move our main directional control valve is drained back to tank on a special drain line, an external drain line, and it moves back to tank on a separate line as indicated here. The small pan symbol is another indication of the very same reservoir that is at the bottom of the diagram, but in this case prevents us from having too many lines on the drawing leading to tank. Moving back to the top of the directional control valve, we see our two main work ports. The one on the left is labeled Port A, and it moves off to a pilot-operated check valve. If fluid moves through this valve, then we're extending the cylinders above. And then we also have our work port B, which if fluid moves vertically from the directional valve and up this main line, then we are retracting the cylinders that are at the top of the diagram. Let's just move the directional valve to get a quick feel once again for the function of the directional valve when we are in P to A flow, extending our cylinders above, and here we are in the lowering mode, or P to B flow through the directional valve, lowering the cylinders above. This machine lifts and lowers a very heavy boom. Back to the center position, with the solenoids turned off, we see that there are centering springs that return us to our center position, which unloads the pump back to tank P to T while blocking our A and B work ports. We see a pressure reducing valve That's the kind that is drawn normally open and piloted on the downstream side. This valve prevents us from using excessive pressure when flow moves vertically on this line up to the rod end of the cylinders to be used while the cylinders are in retraction. So the pressure reducing valve steps the pressure down for the purposes of retraction. And when the directional valve is closed, as it is now, there is also a work port relief valve that is designed to protect pressure in the rod end line going up to the cylinder. If there are any field forces that generate an excessive pressure, the work port relief will open and vent to tank. Whenever you see a check valve that is blocking flow returning to tank, then typically you're looking at an anti-cavitation or a makeup check valve. This is a valve that could provide extra flow from tank to the cylinders while they are being retracted, because remember, this machine lifts a very heavy boom while lowering the cylinders. Gravity is at work, and if there was any loss of flow required and there was a threat of cavitation to the rod end, then extra flow could be drawn in through the makeup check valve. That might occur if there were some difficulties getting the directional valve to open all the way, or if the pressure reducing valve wasn't opening all the way. Whatever the case may be, if while lowering the boom, which is retracting the cylinders, extra flow could be drawn in through the anti-cavitation check valve if needed. Let's just operate the directional valve once again and see how the valves function. This is our function during raising the cylinders. And we see oil returning from the rod end of the cylinder in blue is bypassing the pressure reducing valve on the check valve shown. And while lowering the cylinders, we notice that pressure is reduced across the pressure reducing valve. In both cases, we are using our flow control in the restricted or slow speed mode, and that's making the system quite dynamic, as you'll see that the relief valve is in use even while the cylinders are moving. In the next section, we will look at this issue more closely and learn more of the details of the system. Thanks for watching.
We have hundreds of interactive resources like this live schematic, so you can try out your wild ideas without blowing anything up. Get started at lunchboxsessions.com.